All right, so more 4.4 exponential and logarithmic equations. So we're going to solve the exponential equations by expressing each side as a power of the same base and then equating exponents. All right, so let's see how this goes. All right, so 3 to the x power. So 3 to the x powers, it's already been a prime factorized, right? The 3 there. Now 27 is the same as, I haven't done this in a while, so I'll just review this really quickly. First prime factor that we can divide into a 27 is 3. That gives me a 9. Then we can divide 3 into 9. That gives me a 3. Then we can divide 3 into 3, and that gives me a 1. So the prime factorization of 27 is 3 times 3 times 3. Or we could rewrite that as 3 to the third power. So now we know x must be equal to 3, right? So if 3 to the x power is equal to 3 to the third power, then these exponents must match, right? So this exponent here and this exponent here have to be equivalent to one another. All right, so let's try this one over here. So we have 5 to the x power, and we have 3,125. Okay, so let's see, we have 3,125. So let's say we divide the first one by 5, we get 625. And then we divide that by 5, and then we get 125, and then we divide that by 5, and then we get 25, and then we divide that by 5, and we get 5. Then we divide that by 5, and then we get a 1. So it looks like we have 1, 2, 3, 4, 5 5s. So 5 to the x power is equal to 5 to the fifth power. Therefore, x must be equal to 5. On the next one, the left side's already simplified, so we end up with 5 to the 2x minus 3 power must be equal to, and 125, that is simply 5 to the third power. So what you end up with is 2x minus 3 is equal to 3, right? Now, first we want to get the variable term 2x by itself, so we have to undo the subtraction of 3 by adding 3, and whatever we do to one side, we do to the other. Those cancel out, leaving me 2x is equal to 6. Then we undo the multiplication of x by 2 by dividing by 2, and whatever we do to one side, we do to the other. And that gives me x is equal to 3. Now at this point, you could actually plug all those numbers back in and verify the results, which is not such a bad idea. So let's try this one. Now, this one right here, the left side is not simplified because 4 is actually 2 to the second power. Now you could write this extra step in with an x, but a power to a power means you multiply those together. So what we end up with is really 2 to the 2x power, right? Now 8 is really 2 to the third power. So we'd say, oh, that is equal to 2 to the third power. So what we know now is that 2x must be equal to 3. So what we would have is 2x is equal to 3. Then we divide both sides by 2 to undo the multiplication there. Divide by 2, divide by 2. And therefore, x must be equal to 3 over 2. Okay, so next we have 3 is to the 2 minus x power is equal to 1 over 27. Now, first we can do a prime factorization of that, which basically means it's 1 over 3 to the third. Next, we have to move this from the denominator to the numerator, which means we're going to flip the sign of the exponent. So we end up with 3 to the negative third power. So we end up with 3 to the negative third power. So we have 2 minus x is equal to 3, negative 3. So we end up with 2 minus x is equal to negative 3. So we isolate the variable term, which is a negative x. We get rid of the positive 2 there by subtracting 2. And whatever we do to one side, we do to the other. That gives me negative x is equal to negative 5. Then we undo the multiplication of 1 by a negative 1 by dividing by negative 1, and whatever we do to one side, we do to the other. We end up with x is equal to a positive 5. Or you can just flip the sign, right? If a negative x is equal to a negative 5, then a positive x must be equal to a positive 5. I'll go down a little bit more. Solve the exponential equation. Express the solution in terms of natural logarithms or common logarithms. Then use a calculator to obtain a decimal approximation for the solution. All right, so the first one. So, because this is a 10 base here, I'm going to use a regular log here. So regular log, which has an understood or implied base 10, even if you don't write it. So, and then whatever I do to one side, I'm going to do the other. So I'm also going to take a log of the other side. What that allows me to do is pull this x to the front. Okay. So we end up with x log of 10 equals log 2.22. Now at this point, the entire log of 10 turns into a 1, right? And that should make sense because 10 to what power is equal to 10? 10 to the first power. Okay, so if the base and the argument are the same, you end up with a 1. It's equivalent to 1. And 1 times x is just x. So we end up with x is equal to log, and that's a log of 2.22. Okay, now normally at this point you would plug this into your calculator and get an approximation, but I'm just going to leave it as the exact answer, and then you can try that on your calculators. All right, so let's try this one. Now, because this base right here is an e, I'm going to use a natural log. So I used a regular log because that is a base of 10 here. So over here, I'm going to use a natural log because the understood base of a natural log is an e. So we would end up with, and then here we're going to pull the exponent to the front. So we end up with x natural log of e, and natural log of e just turns into a 1. And that's still equal to, we have a natural log on the right side. So we have a natural log of 21.14, right? So that simply gives me x is equal to the natural log of 21.14. Okay, so let's try this one right here. Now, we're going to want to get this e by itself right here, right? So I'm going to undo the multiplication of e by 2 by dividing by 2, and whatever I do to one side, I do to the other. Those cancel out. That gives me e to the 5x power is equal to, and then we take half of this, so that is 593. Okay, now at this point, now that I have an e here, I can take the natural log of both sides, right? Which allows me to pull this exponent to the front. That simply gives me 5x natural log of e is equal to natural log of 593. Now, the natural log of e is going to turn into a 1. So this 5x times 1 is simply 5x. And that gives me natural log of 593. Now, in this case, we're not done, though, because our x has a 5 coefficient. So we have to undo the multiplication of x by 5 by dividing by 5. And whatever we do to one side, we do to the other, giving me x is equal to the natural log of 593 all over 5. Okay, I have a couple more. All right, so in this case, we have 2 to the 2x plus 4 is equal to 7x minus 5. Okay, so let's dive into this one. We're going to take a natural log of both sides of the equation. Whatever we do to one side, we do to the other. That will allow us to pull this exponent down to the front, which in this case would give us 2x plus 4 in front. And in the first case, we're just going to pull this entire x minus 5 to the front as well. So we end up with 2x plus 4 times the natural log of 2 is equal to x minus 5 times the natural log of 7. Next, we're going to distribute the natural log. So I'm going to keep these things within the parenthesis in front. So that's a 2x times natural log of 2 plus 4 times the natural log of 2 is equal to x times the natural log of 7 minus 5 times the natural log of 7. So we're kind of distributing, right? So distribute there, distribute there, distribute there, distribute there. Okay. So at this point, I end up with, these are constants, by the way. These are very ugly constants, but they are just constants. Natural log of 2 is a number. It's not a rational number, but it is a number. Okay, so same thing over here. These are just numbers. They're very weird numbers, but they're just numbers. Okay, so we don't want to overthink those. Those things are like 2, 3, 4s, and 5s, except they're not rational numbers. Okay, so at this point, we want to get all the variables on one side, all the constants on the other. So I'm going to get rid of this positive x on this side. So I'm going to subtract x ln 7 from both sides. Negative minus x ln 7 And I want to get all my constants on my right side, so I need to get rid of this positive or undo this addition right there. So I'm going to subtract 4 natural log, sorry, of 2 minus 4 natural log of 2. So these cancel out over here, and these cancel out over here. And that leaves me 2x natural log of 2 minus x natural log of 7 equals negative 5 natural log of 7 minus 4 natural log of 2. Okay, now at this point I'm going to factor an x out of the left side, and that leaves me 2 natural log of 2 minus natural log of 7 is equal to negative 5 natural log of 7 minus 4 natural log of 2. Right? And now we're going to undo the multiplication of this x by this parenthesis with the 2 natural logs of 2 minus a natural log of 7 by dividing by 2 natural logs of 2 minus natural log of 7. And whatever I do to one side, I do to the other, so I end up with 2 natural log of 2 minus natural log of 7. So on the left side, these cancel out. And we end up with x is equal to this over here, so I can just rewrite it if I wanted to. So negative 5 natural log of 7 minus 4 natural log of 2 all over 2 natural logs of 2 minus a natural log of 7. All right, so let's do the second one. So the second one, first one, we're going to factor this. So the square root of e for x is going to be e to the 2x. And then we're going to have e to the 2x in the first place as well. And that should make sense, because if I multiply these both together, 2x plus 2x is 4x, right? Or to put it another way, if you take the square root of it, it's going to be half of the 4x is going to be on each of them, right? So half of 4x is 2x, 2x and 2x. Okay, next we're looking for two numbers that we can multiply together to give you negative 35, that if you add together give you a negative 2. So since it's two numbers that multiply together to give you a negative, one's going to be positive and one's going to be negative. With the negative being stronger, so it's going to be 5 and 7, with the 7 being the negative and the 5 being the positive. Okay, now because we factor these out and they're set equal to 0, we're going to use the zero factor property, which means that we're going to set both of these factors equal to 0 and solve. So far we're solving this just as if it was a regular parabola with substitution. I'm not doing the substitution, but it's the equivalent. But now we're reaching the point where we're not going to be able to finish solving this without using a log. So now we want to say minus 5. We're going to solve for the e to the 2x power. So then we say plus 7. So we end up with e to x is equal to negative 5. And then we end up with e to x is equal to positive 7. Now at this point, I'm going to take a natural log of both sides. Right, natural log, both sides. Okay, and that allows me to pull this 2x to the front, 2x. So we end up with 2x. Now the natural log of e is simply equal to 1. So the whole thing turns into 2x is equal to natural log of negative 5. And we're going to solve for the x by dividing both sides by 2. And that gives me x is equal to the natural log of negative 5 over 2. Now, this is not a valid thing, because if you try to take the natural log of a negative, you can't do it. So the argument can't be negative, so this one right here is actually not a valid answer. Algebra's right, we just don't get a valid answer from that one. So let's move on to the other one, where we have natural log of e, and we pull this 2x to the front. And we end up with 2x is equal to natural log of 7. Now at this point, the natural log of e just turns into a 1, so we're left with 2x is equal to the natural log of 7. And then we undo the multiplication of x by dividing by 2, and whatever we do to one side, we do to the other, which gives me x is equal to the natural log of 7 over 2. And there you go.